Welcome back to the virtual classroom of Chem Based School of Chemistry. Sound clear? Can all of you hear me clearly? Right, we are at the last bit of the study pack 1.2, which is moles, molar volumes, and the gas laws. In fact, we completed the concept of moles. We had a detailed discussion in the last session on concept of moles. And today to continue with the molar volume, last bit of it, I think I did molar volume as well in the last class. Almost most of the questions I did, and I told to try some of the questions. And then I left few of the questions to be discussed today, the last few questions, today to continue and complete the tute with the gas laws. Now, let me know if there any difficulty from what we discussed in the previous tute from the moles and the molar volume. Any difficult ones? I hope you have tried all the questions. It's a must that you try all the questions. You have to do it, right? Then you will know the difficult areas. I can help you with that. So did you try the last few questions, at least the last two questions? And get me the answers if so. So we'll start with the last two questions, and then we'll complete the gas laws. The last two. The answers, please. I think I did up to the question 10 or 9 in the last class, and I told to try the last few. They're all similar. Question 10 and 11 almost same. So can someone tell me the answer for question 12? No one has done it. Can you please try now? Question 12. I'll give you a minute. Question 12. It says what volume of oxygen gas is required for the complete combustion of 120 cm³ of butane. But the first step would be to construct the balance equation for the reaction of butane with oxygen. So C4H10 plus O2 gives carbon dioxide plus water. Then balance the equation. For carbon is balanced. 5 times 2, 10 hydrogens. And as for the oxygen, 4 times 2, 8 plus 5, 13. So it's 13 over 2 oxygens, right? So the question is, what volume of oxygen gas is required for the complete combustion of 120 cm³ of butane? So the volume of butane is 120, right? And then you need to find the volume of oxygen, right? So what you can do is first you find the moles of butane, right? Once you know the moles of butane, that into 13 over 2 is the moles of oxygen, because the ratio is 1 is to 13 over 2. The number of moles of C4H10 is volume divided by molar volume. Let's check whether it's STP or RTP. It says STP, so you have to use the molar volume under standard conditions, which is 22,400 in cm³, because the volume is given in cm³, which is decimeter, divided by 22.4. And also if it is RTP condition, then you should divide by 24 or 24,000. cm³ 24,000, dm³ 24. This is the number of moles. You don't need to use the calculator for this. You leave as a fraction, use the cal in the last stage. I always say if it's a multi-step calculation, don't use the calculator in the each and every step, because you round up in each and every step. So what happens finally, you round up 3 times, your final answer will go wrong. So leave as a fraction, and then you find the number of moles of oxygen. Number of moles of oxygen will be this times 13 over 2, because ratio is 1 is to 13 over 2. This times 13 over 2 is the number of moles of oxygen. And now you can find the volume. That is the moles of oxygen. That's the previous answer. Times the molar volume, which is 22,400. Now see how easy it is. When you leave as a fraction, you can easily calculate. So it is 780 cm cube. So 120 cm cube of butane needs 780 cm cube of oxygen. In fact, 780 is 13 over 2 times of 120. 120 times 13 over 2, you get 780. Got it? You can try the last question, please. This is what volume of hydrogen at room temperature and pressure. It should be actually standard temperature and pressure. Just please correct it. It says STP here. Is given out when 0.325 grams of zinc reacts with hydrochloride. First, you construct the balance equation. And then from the mass of the zinc, you can find the moles of zinc. The mass or molar mass is the moles of zinc. So the moles of zinc will be equal to the moles of hydrogen because the stoichiometry is 1:1. So once the moles of hydrogen is known, you multiply by the volume, the molar volume, which is 22,400 if you need the volume in cm cube or milliliters. If not, if you need the volume in decimeter cube, you multiply by 22.4, you can get the answer in decimeter cube or in liters. So first you find the number of moles of zinc, that is the mass over molar mass, 65.4. You have to use the exact values. So number of moles of hydrogen is the same. Leave as a fraction. The reason is 1:1 molar ratio. And then you can find the volume of hydrogen, which is the moles times molar volume. I get the volume in decimeter cube, 22.4 decimeter cube. What's the answer? .11 em cube. Correct? Any questions? Any other questions which is difficult before I start the gas laws? Because we left many questions in the last lesson, concept of moles and molar volume. And I did the important questions, the similar ones I left for you all to practice at home. So I hope that you have tried all the questions, right? You know, if not, we'll start the gas laws. Right, so let's start on the gas laws. Right, the gas laws, mostly we study in physics, all the gas laws, but here we only study Boyle's law and the Charles law. And with the help of the Boyle's law and the Charles law, which are referred to as gas laws, we derive the universal gas equations. And then the universal gas equation, of course, there are derivatives of the equation as well. From the universal gas equation, we find various, like pressure, the temperature, and the volume of a gas in a given system. So to explain, to begin with to start with the Charles law, the Charles law states that the volume of a gas is directly proportional to the temperature at constant pressure. That means a given mass of a gas, that means you have to keep the mass constant, at constant pressure, the volume of a given mass of gas at constant pressure is directly proportional to the temperature. Which means if you increase the temperature, the volume of a gas simultaneously increases, and if you decrease the temperature, the volume of the gas simultaneously decreases. So if I want to plot a graph of temperature versus volume, temperature in Kelvin, right? We get a graph like this. Because temperature is the independent variable, the variable being manipulated. So we're studying how the changes in temperature affects the volume. So the x-axis has to be temperature. And then you have another graph. This is Celsius, temperature in Celsius. And then this is the volume. 0 Kelvin is minus 273 Celsius. That's the absolute zero. 0 Kelvin is absolute zero. So you get like this, right? Of course, you have different gases. You got different lines for each gas, like this. So this is how the volume of a gas changes with temperature. So first we'll write the Charles law. The Charles law states that the volume of a known mass of gas, Charles law states that volume of a known mass of gas at constant pressure, volume of a known mass of gas at constant pressure is directly proportional to the temperature. Right, so you can copy this. So volume is directly proportional to the temperature at constant pressure and constant mass. Or we can say volume is equal to constant times pressure, because you can get rid of the proportional sign, introduce a proportional constant. Therefore, V over T will be always a constant. This is a straight line. Please copy this. No, as a law, as a gas law, what is Charles law? They will not ask at the exam, but you need to know the gas law, because that will be helpful for to derive the universal gas equation. Universal gas equation they will ask. The universal gas equation is derived from the the Charles law and the Boyle's law. But what is Charles law? State the Charles law. State the Boyle's law. No, such questions is in physics. Physics you need to know, yeah. Right. So next we'll see the Boyle's law. The Boyle's law states that the volume of a gas. Now, these Charles law in the Boyle's law explains how the volume is affected by temperature and pressure. So Boyle's law states that the volume of a gas is inversely proportional to the pressure. It's inversely proportional to the pressure. That means if you increase the pressure, the volume is going to decrease. If you increase the pressure, volume is going to decrease, right? Inversely proportional, right? At constant temperature, and of course, a constant mass of a gas. Because temperature has to be kept constant. If you're explaining how the temperature affects the volume, the pressure should be kept constant. If you're explaining how the pressure affects the volume, the temperature should be kept constant, because temperature and the pressure are the two factors which affects the volume of a gas. So if you're explaining one factor, effect of one factor, the other should be kept constant, right? So we can get rid of the proportional sign again, introducing a proportional constant. And then we can say PV, therefore, is a constant, right? So there are different ways to express the Boyle's law. So when you plot a graph, it says to plot a graph of V versus 1 upon P. So here, the independent variable is 1 upon P, because the independent variable is a variable being manipulated, change. That's always the x-axis. And as for the y-axis, that's the dependent variable. The dependent variable is the observed effect of the independent variable being manipulated. So you get a straight line because it's directly proportional. So likewise, when you plot a graph for the pressure versus volume, that is 1 upon P versus volume. This is pressure versus volume. As the pressure increases, the volume decreases. So it will be like this. As the pressure increases, the volume decreases. Then you have PV versus P. It will be a straight line because P times V will be always a constant. Because if you increase the pressure, the volume decreases. If you decrease the volume, the pressure increases. Right? If you increase the pressure, volume decrease. If you decrease the volume, the pressure increase. But just that's inversely proportional. So always remember, the pressure times volume will be a constant. Right?